Today in 8th grade, we're going to be working on dilations. Dilations are images produced by either enlarging or reducing a figure. And one thing I want you to remember that if it's an enlargement, we're going to again talk about a scale factor. The scale factor is going to be greater than 1. If it's a reduction, we're going to find that it's going to be less than 1. So the first problem that we're going to try is we are going to actually create the dilation when we're given the scale factor. In this case, the scale factor is going to be 3/2, which 3/2 is larger than a whole. If I made that into a mixed number, it would be 1/2. But for our purposes, we're going to leave it as an improper fraction. Because it's being taken times a scale factor greater than 1, we already know that this is going to be an enlargement. Okay, so to create the dilations, what we're going to need to do with each ordered pair, each coordinate of the ordered pairs, is we're going to need to multiply each coordinate by the scale factor. Okay, that's what we're going to do, is we're going to multiply each coordinate by the scale factor. Let's first plot our originals. Okay, A is -2, -1. Plot it and label it. B is 2, 3. C is 2, -1. And we're going to connect those to create our figure. Whoops, let me go back and correct C. C is 2, -1 right here. Now you should have this on your study guide if you would like to follow along. They have this one worked out, but follow the steps as we go, please. Okay, so now what I'm going to do is I'm going to create a new figure. My new A, this is the ordered pair here. My X and Y coordinates will go over here. What I do to each part, my X and my Y, I will take times 3/2. So here's the math. -2 times 3/2. Now you're familiar with your fractions and canceling out. What's that equal to? Good, a -3. Then I'm going to take the Y coordinate, -1 times 3/2. And what do I get? -3/2. We're going to go ahead and write that as a mixed numeral, -1 and 1/2. Everybody okay with that? All right, great. Now let's plot our new A. And we're going to call this with a superscript of A. -3, 1, 2, 3, -1.5, 1.5. Okay, so this is our new A. Now let's try point B. I'm going to take 2 times 3/2, which what do I get? 3. And then 3 times 3/2. I'm taking each of the ordered pairs, the X coordinate times 3/2 and the Y coordinate times 3/2. And what do I come up with here? Right, I get 9/2, which I'm going to go ahead and make into a mixed number of 4 and 1/2. Everybody okay with that? All right, let's plot that then. I have 3, 1, 2, 3, 4.5. 1, 2, 3, 4, and 1/2. Okay, that's my new B. And the last point is our C. X coordinate is a 2, so we're going to take that times 3/2, and you get a 3. And the Y coordinate's -1 times 3/2, and I get -1.5, just like we did up here. So let's plot that ordered pair. I have 1, 2, 3, -1.5. That's my new C. Let's connect those points. And I have a figure that is 1.5 times as large as my original. So we had an enlargement this time. Because the scale factor was greater than 1, we created an enlargement. Make sure that you label your new figure and that you have your original labeled as well. Okay, Okay, the second example that we're going to go through is if they give you two figures. Now these are just segments, but they give you two figures. They want you to find the scale factor of this dilation. How do we do that? Well, you do it by always taking and comparing your ordered pairs. You're going to compare your new to the original. This is the key right here. Now I've already plotted, or we figured out what the ordered pairs are for my original n, which is 1, negative 2, and m is negative 2, 1. Now you might have to find these. My new n is 2, negative 4, right here, and my new m is negative 4, 2. Now just looking at this, going from the original, this is your original, right here, to the new, is this an enlargement or is it a reduction? Yes, it's an enlargement. So we know that whatever our scale factor we come up with, it should be greater than 1. Now how do we find out? Well, we're going to compare any ordered pair. Let's just compare the n's. And you compare the x-coordinates in each one. And we just write it as a fraction. We write it as a ratio or comparison. We do new to original. So we have a 2 to 1. Okay, even if we compare the y-coordinates, always go new to original. So this would be negative 4 to the original of negative 2. That simplifies as 2 to 1. And we could do the same thing here. And we end up every time getting a 2 to 1, or we can say our scale factor is 2. So you've just found the scale factor of these two figures when it was enlarged by a scale factor of 2. All right, at the bottom of your study guide, we're going to have you do a couple practice. I'm going to give you a chance to work them on your own, and then we're going to come back and go over them. Let's just look at the first one. The first one, they give you 4 ordered pairs, A, B, C, and D. You're to plot these and then figure what it would be if it's dilated with a scale factor of 1/2. Okay, your B is negative 1, 5, C is negative 3, negative 5, and D is 3, negative 4. Okay, you're going to plot those, connect the ordered pairs, and then find out what your new ones would be. Okay, I'll give you some time to work. All right, when you plotted your original, you had 2, 4 for your original A, negative 1, 5 for your original B, negative 3, negative 5 for your original C, and 3, negative 4 for your original D. Okay, let's connect those. Now, because you are using a scale factor of 1/2, is this going to be an enlargement or reduction? Good, it's going to be a reduction. So let's figure out what our ordered pairs are. I'm going to take each coordinate times 1/2. 2 times 1/2 is 1. 4 times 1/2 is 2. So our new A is going to be the ordered pair of 1, 2. Our B, I'm going to take negative 1 times 1/2, and you get negative 1/2. And take 5 times 1/2, and I get 5/2, or let's make it into a mixed number, 2 and 1/2. Okay, that's your new B. Negative 1/2 up 2 1/2. C, I take negative 3 times 1/2, which you get negative 3/2, which is the same as negative 1 1/2. And then I take a negative 5 times 1/2, which gives you negative 2 1/2. So negative 1 1/2 minus 2 1/2. That's your new C. And your last one, your D, 3 times 1/2, which is 1 1/2. And your y-coordinate, negative 4 times 1/2, gives you a negative 2. So I go over 1.5, down 2. That's your new D. And then let's connect. Remember, it should be a reduction. It should be smaller than your original. Is it? Yes. Does it look like it's similar, the same shape? Yes. Then you're probably okay. You've done all your mathematics correctly. And you have created your new graph that is dilated with a scale factor of 1/2. All right, now let's go to the bottom. They give you 2 segments. Now clarify which one's the new, which one's the original. Without the little apostrophe, you might say that's your original. And then your new is the one with what I call the little apostrophe by it. Okay, I'll give you a moment to work this. Find out what the scale factor is and tell me if it's an enlargement or reduction. All right, first let's get your ordered pairs for original. What's the original ordered pair for P? You get -3, -3. Okay, and Q? 3, 0. Okay, now what's your new P? Your new P is -2, -2. And your new Q is 2, 0. Okay, now I'm going to make a comparison to any of the order pairs. Let's do the X. Let's do the P's. We're going to compare new, remember it's always new, over original. About that. Okay. So the new was a -2. Your original was a -3. And we can simplify that to 2/3. Even if we did our Y's, it was a -2 to 3. Remember, it's always new over the original. And either time we come up with 2/3. Now you notice if I did this Y comparing each other, it would be 0 over 0. If that happens, you need to pick another one of the coordinates to compare, because that's kind of going around then not giving you your rate or scale factor. Okay, so your scale factor is 2/3. And is it an enlargement or a reduction? It is a reduction. Are there any questions? All right, today we have gone over how to make a scale drawing, a dilation based on given a scale factor. And then we've also learned to calculate the scale factor and find out if it was a reduction or an enlargement.